Let's moving on to the next information. We call it nitrogen rule. Okay. All right. Let's take a look at it. So let's focus on understanding how this works. Don't just memorize it. Okay. You can actually understand this. If you learn about the degree of unsaturation with me, this shouldn't be that hard. Let's take a look. Okay. All right. Nitrogen rule. You can go read all this, but let me explain. Okay. All right. Put your pen down. Just listen. Nothing to write in here. Most molecules have even mass number, even molecular weight. For example, methane, you count, so carbon is 12, hydrogen is 1 each, this is 16, ethane is 30, propane is 44. Okay, so most compounds have even number of mass. All right. Now, when you add an oxygen, think about this. Each oxygen weighs 16 atomic mass unit. Okay, start out with 16, add another 16, even and even, you're gonna get even number, right? Just simple math. 30 plus 16 even plus even, you get even. Even plus 16 even, you get even. Okay, so even plus even, you get even anyway. So that's simple math. Now let me say this. Next one, I'm gonna add from 16, 30, or 44, any one of this. Okay, I'm gonna add chlorine or bromine. Let's take a look at the weight of chlorine and bromine. So bromine is 79, chlorine 35. When you add chlorine and bromine, let's take a look. Even, let's say bromine plus odd, how come you get even? If some of you recognize it by now, okay? If some of you remember the degree of unsaturation, when you add bromine or chlorine, halogen in general, it replaces one hydrogen. So essentially, you're not actually adding 79. You're adding 79 and minus 1 because it replaces that one hydrogen, okay? So basically, you add 78. Even plus 78 even, you get 79 minus 1, right? So you get even number. Same thing with chlorine. It's not like you add 35 onto 30, right? You actually replace one hydrogen, you add 35 and minus 1, you get 64. Okay, so adding oxygen or halogens, you're gonna get an even number no matter what. All right, now a little bit tricky. Nitrogen. Okay, nitrogen is 14. All right, 14 add on to 16, you think that you should get 30, you should get even plus even, you should get even, but no, you actually get odd number because nitrogen can form 3 bonds. Okay, but every time when you add a nitrogen, it brings a friend with it, right? So we have hydrogen that come with it. Okay, so you should actually add 15, not 14. All right, so 16 even plus odd, this is 15, you get odd number. 30 even plus odd, you get odd. Okay, so basically my point is, if a molecule has an odd number of nitrogen in the molecule, the molecular weight is going to be odd. Okay, now what if we add 2 nitrogen? Okay, well, you're going to get double odds. You get even. You add 30 AMU. So from even, you're going to get even at the end. Okay, so even number of nitrogen, the molecular weight is even. All right, let's see if you understand what we just did. Pause the video, do on your own. Okay, then check with me. All right, so let's say this compound A, there's no nitrogen, the molecular weight gonna be even. You can count on your own. This is an 86. Okay, in B, no nitrogen, gonna be even. C has an odd number of nitrogen, you're gonna get odd, and even number of nitrogen, you get even. That's it. Okay. When you have a mass spectrum, you're gonna do this in reverse. You're gonna look at the molecular weight, the molecular ion peak. If the molecular ion peak is odd, it tells you you have an odd number of nitrogen, 1, 3, 5, and so on. If the molecular weight is even, either you don't have nitrogen, 0, okay, or you have 2, 4, 6, and so on, number of nitrogen. All right. Okay, all right, that's nitrogen rule. Okay, so we have right now, so far we have learned molecular weight, nitrogen rule. We're going to move on to the M plus 2P. This is fun to explain. Let's take a look at the next video.